Before I begin, I just want to do a warm introduction about myself. I'm currently a robotics trainer. I'm also the training and curriculum lead in Robotics and Automation Center of Excellence. RACE, in short, is a subsidiary of PBA Robotics. And PBA Robotics does many different kinds of research and development, and they are also a local robotics manufacturer, meaning we manufacture our own robots here in Singapore, and then we supply them to different people. A-Star, we supply them to um, other MNCs that want to use it. So what we do is, being a manufacturer, we take that, we synthesize, and then we train people that the current workforce that are coming in. I'll share more about that, leading towards this. So what I do is I direct and I deliver robotics curriculum in RACE. Right now, our current venture is running our SG United programs. And this is one of the pathways to enter in the robotics industry. There's many different pathways to achieve that goal. All right, I just share a little bit about my education background. I actually come from Singapore Poly. I was learning aeronautical engineering. And from there, I went on to learn about electrical and aerospace engineering. And that's where I had my first ever formal robotics training, right, in Ross. Okay, so right before that, what I did was I was in the 3D printing industry. I spent over 2 years in the 3D printing industry and going across Southeast Asia, maintaining the different suppliers who manufacture different products. So based on that experience of 3D printing and robotics, which go hand in hand, I found it to be a suitable skill set to enter. And true enough, now I am in RACE delivering this content, and I'm happy to share with everyone what are the different skill set. But first and foremost, I'll share a little bit more about what I'm going to be covering today. Next slide, please. All right, so some of the things I'll be covering is what is robotics and what are the types of robotics. And I'll share a little bit about AI. We do have some AI in robotics. And as you know, AI is an umbrella term for many different types of branches, right? It spans across so many different things. But I'll just talk about something more familiar today, which is robotics. And I'll have a short pause in case anyone wants to ask any questions. After that, I'll go into what are the skills required. There's not one too many. There's not one specific skill or two specific skills, but what is currently being used in the industry. And then I'll have another break for Q&A if anyone wants to ask any questions. And then I'll go about how to go about it at the last part. Hopefully being able to inspire some of our youth to enter the tech industry. All right, next slide, please. All right, I'll start about how robots came about. So basically, robots are something that can perform repeated tasks, right? So in the past, something with as what you can see in the image there, what you can see is that there's farmers, going about their labor, and it's a very labor intensive job. And right now, fast forward, we have a lot of automation to solve that for us, and that's where the first robots were formed, right? In fact, Da Vinci also created a robot in the past. Right? Fast forward in the early 1900s, one of the first few robots that were built were actually the robot arm you see in the on the extreme right. So that's actually an industrial robot. So think about it as like cranes, right? But but it can move on its own, right? It can, but of course you have somebody to set its movement, etc. So robots, it's not something new. It's been there since the early 1900s. It's still here now, and then we're starting to learn a little bit more about it. As technology advances and education becomes easier and more accessible, more and more people are getting to learn about it. Okay, next slide, please. So I'm going to share a little bit about industrial robots. I know there's a lot of robotics going on in school, in the primary, secondary level, and that's where I first garnered my interest in robotics. I was myself a part of the robotics club in primary school, where I first started out with Lego Mindstorms, and I played with it. That itself actually is a good starting point, right? But in industrial robotics sector, we have basically three major branches where there's manipulators, there's mobile robots, and there's automated material handling robots. So most of the robots are being used in the logistics industry. They are being used in the factory setting industry, manufacturing, logistic, and FMCG, fast-moving consumer goods. That's where most of these robots are, to really speed up the process of manufacturing. Let's say I want 1,000 pieces of shampoos to be supplied to shop ABC. So it's hard to get people to have that output, right? Because people need to rest, people need to take time off, people need to eat, etc. Robots can run 24/7 and probably get it done, in over a day, right? With what we have right now. So I'm just going to share on the surface what is going on in the industry. All right. Next slide, please. All right, can we play the video? So this is one of the robots, what we call parallel manipulators. All right. So what this robot does is it picks and places in a computer setting. So this is what usually happens in a lot of so there will be many different products being produced, and it needs to be packaged. The quality needs to be inspected. So these robots, they will be installed in their manufacturing lines to help them improve their throughput, to help them improve on their quality. Right, and there's so many things that go on beyond just the arms that are picking it up, right? There's some sensors going on, which is a huge part of robotics as well. Sensors that detect whether the product is up to standard, sensors that detect whether the product is in place for it to be picked up. So this is one of the applications of robotics. As you can see here, it's on the packaging stage already, and then ready to be shipped out and delivered to its customer. So in the industrial setting, this is the applications of robotics. Next slide, please. Okay. So as you can see here, it's a bit blurry on my end, but industrial robots are one part of it, and then there's something called the collaborative robots. So this is something new, in the 21st century. Collaborative robots are something different, right? So they are robots that work together alongside human workers. Right? In the past, industrial robots work in the manufacturing line, doing the pick and place, but they're typically in cages. because the force that it exerts can be fatal to humans. There has been so many cases of decapitation and injuries, etc. So now, with advancement in technology, more safety sensors are being used in place, and now there's such a thing called collaborative robots that can work alongside humans. So imagine you are, maybe you're doing something and then you put it on the side and then the robot arm picks it up for you. Or if you have watched Iron Man and then when he takes off his suit, right? Sometimes the arm can be dangerous, but with advancements in technology, it's possible now and it's safe for robots to work alongside humans. So one of the key things that the advancements in the technology, one of the key things is that the safety mechanisms. So they have this thing called a force torque sensor. Upon any force that hits, it feels some contact, it will stop, and then we'll ask the operator, "Is everything okay?" So then it will. If you say, "Okay, actually it's just a minor, it hit me, but I'm still fine. Carry on," and it will continue doing its work. So that's collaborative robots. Next slide, please. Other types of robots, other than industrial robots, are mobile robots. I believe this is more commonly seen in the public nowadays. You have seen them in some hawker centers. You've seen them in some coffee shops where they go around picking up trays, or you've seen them move about in hospitals. But the main application of mobile robots are in the logistics or warehousing industries, right? They are robots that are able to move in the environment, either using wheels or legs, right? It can perform many different tasks. What one of the main key tasks that it does is it transports one item from one place to another. So you reduce the impact of a labor intensive task for a human to push from one end of the factory floor to the other, and being able to push a lot, being able to push a lot of weight on it, right? What From my experience, mobile robots that are running on their own carrying stuff, one of the heaviest payloads I've seen is 8 tons, right? 8 tons. So that's a very, very, big robot. But actually, the one that's carrying the 8 tons looks just slightly bigger than the size of a car. So it's not that big actually, right? So it's able to carry a weight of 8 tons. I don't know where that's applicable. I didn't ask the client, but it's able to have that sort of capabilities. But on a real scale, being able to carry packages, carry boxes across autonomously and work 24/7, right? They need to charge for a while and then another robot comes on. So this will increase the productivity of the factory per se. All right. So I'll share more about this as well. We've got another video to share as well. Next slide, please. Okay, so it's something to share with you what my company, PBA Robotics, has been working on. And right when COVID started, we realized that, hey, this is something that happened, and we want to do our part using robots, right? There's a lot of minimal human interactions. That's what robots are for. So during this time, if you can see on the extreme right of the photo, there's a sunburst UV robot. That is something that we developed, and we tested it out on the public, and then now it's actually still running. And what it does is shoot UV rays to disinfect. So there's many different types of disinfections. There's sprays, but what we do is we emit ultraviolet light. Right, this is harmful for humans. So whenever this is in operation, when there's no humans around. All right. Next slide, there'll be a video to share more about it. Next slide, please. So this robot is running at North Point in Yishun. Of course, it's running after hours to disinfect the whole area of North Point. So this robot runs and it disinfects the areas with minimal human interaction. Right? So how it works is this robot will map out. Right? It uses this sensor called lidar. Right? Lidar senses light, distance, and ranging sensors. So using this technology, it it can scan the whole area and then it maps the whole area out, therefore allowing it to move around on its own. Next slide, please. So that's a little bit about the robots that we work with. So there's also safety sensors on this. Maybe you can click at the white part of it. Okay. So that is mobile robots. Other types of robots that are also out there are field robots. There's a lot of talk about drones in Singapore. Recently, CAAS released a licensing method, right? That you have to take a license to be able to fly the drone. So it looks to be going up as well, but drones are actually aerial robots, right? Robots that can fly, right? Because is able to with minimal interaction, press play and then the drone flies around if you've programmed it right. AGVs are quite similar to AMRs or mobile robots. They are robots that run on the ground, right? And one of the very, very interesting examples is actually the rover, right? Recently, NASA has landed on Mars, right? And then the robot was called the Perseverance, right? It landed on Mars, and then now it's moving around and sending photos, etc. So it's also a robot, and it's using one of the key things that we in the robotics industry work on, which is the framework of ROS, which is Robotic Operating System. All right, we'll share. As you go on into the robotics industry, you might or may not have heard of it, but it's something that a lot of these robots have in common. Okay. And robots can also work underwater as well. Next slide, please. Right. So, why do you need it to work outside? Because you have to cover a big land, right? Sometimes you have to inspect your crops, whether they are working well or not. Um, Therefore, you would need, it makes sense to have a robot outside. But why would you need a robot inside the house? Right? Is because it makes your life easier. And one of the more famous domestic robots is actually the Roomba. And I think some of you may have had the Roomba at home, or a Xiaomi vacuum robot. So it itself is a robot because it is able to make a decision on its own, right? So you just press play and then it goes around vacuuming, and it keeps your house neat, right? So that is one of the examples of domestic robots, and it's actually pretty smart. Okay, next slide. Another type of domestic robots that is also up and coming is actually robots that are able to cook or do some kind of chores that can help you out, right? There's a burger flipping robot, and there's also an omelette making robot in Yotel, Singapore. Yotel is a hotel that my wife works at, and she's also an advocate for robotics, right? What happens in a hotel is that instead of having bellhops or bellboys that goes to a room to give you what you want, let's say you want an extra pillow, you want extra toothbrush, etc. Usually there's someone that you call and then it goes up to your room, right? In your hotel, there's a robot that does that for you. And in its restaurant where you have breakfast, there's a robot that makes the omelette for you as well. So that is also another use case, right? You don't have to have a human there, but you have a robot cooking, doing the cooking for you. So that's one of the examples. Next slide, please. Okay, so that is one of the things that, sorry, those are the examples of what are the types of robots that are out there, being in industry, being in the, domestic setting in your house, or even out where you have your you have your meal in restaurants. So those are the examples of what are the robots out there. So for this part, I'm going to show you more about what are skills that are being used right now in the industry, and what are the skills that are prevalent, or rather, as part of a robotics engineer. Maybe I would like to have one or two questions if anyone has at this current point.
Right. So if anyone has any questions, feel free to either put it in the chat, or you can actually just speak to Amir online. If not, then
Sure.
I think we can move on. But anyone has any question? Amir did give an overview about the different types of robots that are used in different industries.
Okay. If not, I can continue on the skills part. What are the skills required? Thank you.
It's well explained. Okay, so I think there will be a second Q&A section at the end. So let's continue. Amir, thank you.
Sure. Thank you, Liana. Okay, so being in the robotics industry and doing robotics training for mid-career professionals that they come in to get skilled, and then they eventually go out to do some sort of robotics or automation job, right? One of the key things that I found out is mechanical design becomes an essential skill for robotics. Building robots, you would have different types of designs, right? And in the past, what they do is they have engineering drawings where they have big A3 size paper, and then they start drawing isometric views of certain things. But right now, design with computers and with advancements in technologies is made easier for us to learn how to design, right? And the use of CAD, right, computer aided design software, right? With the use of CAD software to design a machine, it makes it a lot easier, and you are able to prototype different designs. And two of the more famous types of CAD softwares are SolidWorks or AutoCAD. I think some may be familiar with AutoCAD, and some of you may be in the industry, may be familiar with Pro-E. All right, these are CAD softwares that helps you design mechanical parts, and then you assemble them together, and it becomes one solid piece in the assembly, right? So how it is beyond just design. Some of the things that you can also get out from CAD softwares is being able to see what type of load is being stressed on it, right? So imagine building a shaft, and then you have your bearings inside, and then you have your chain, etc., and you put them all together, and then it looks good, right? But then you might also consider, once the weight is being pressured on that certain area, what will happen then? So CAD software will help you with that. Next slide, please. Right. So there's also mechanical simulation, which is on a lot of design softwares as well. So imagine that you build something and there's supposed to be a stress on that, right? So you want to know how much force it will take before it actually breaks, right? You need to know. This is important in robotics. If you create something and then you design, you spend so much time, and then when you put it up, then it breaks in 2-3 days. So you need to figure out the mechanical load on it. So using CAD software, you can find out using simulations. And one of the ways is finite element analysis, where you can virtually find out via simulation whether it can theoretically take the load or not. And next slide will be how it looks like. Next slide, please. Right. So it will look a little bit like this. So when this is an example of a part, so that when the stress is being applied on a downward force, you can see that the blue parts are okay because they are mechanically sound, but the green parts may exert a little bit more force than the other. So knowing this beforehand can help you, think about your design and say, hey, maybe my design isn't that strong. I have to make this part a little bit thicker. I have to make this part, in a different shape. And the use of computer-aided design software is it helps not just from simulation but also in prototyping. And in my experience doing 3D printing, it is a core key skill for you to start your 3D printing career, right? You have to know, you have to design something, let's say in SolidWorks or AutoCAD, and then you export it out in a certain file format, and then you send that file into the 3D printer, and then you see it being fabricated in front of your eyes. So this is also not just a key skill in robotics, it's a key skill in 3D printing as well. And there's SolidWorks and AutoCAD licensed software. So you might have to pay them unless you're students at universities or polys. You might get to use them for free. There's also other types of free software online that you can try to get your hands on and try to design something. One of the key ones that I was made known of by one of my trainees was something called Tinkercad. Right, over there it's online, and then you can start to design something online at tinkercad.com. So you can maybe try to see it out. Next slide, please. Another key skill in robotics is definitely, you see the robots, they definitely have wires running around. So another key skill is electrical and electronics. And why do you need them? You need them to prototype. You need to solder some of your components, and then you need to know a little bit of signal processing. But control theory in robotics, that is key, right? You're building a robot and you want to control it, right? So control theory is one key skill of it. PID or PWM, these kinds of concepts may come into place, right? And low-level electronics. What are low-level electronics? I'll share more in the next few slides. But electrical and electronics are one of the key things for prototyping. And as you can see in the photo, there's an Arduino board, and that's where a lot of hobbies start, right? They start with the Arduino board. With the Arduino board, what it does is it's able to give out signals to move the motor or take in a sensor, etc. And that's the key building blocks of what a robot is about. All right. Next slide, please. Yes, so another key skill is embedded systems, or I would call it, generally call it programming. All right, programming beyond just on the computer. Sometimes you may, programming is quite a big blanket statement, right? It is because a lot of the programming concepts are applicable in a lot of different areas. But the specific one I'm talking about now is embedded systems. So what are embedded systems? Embedded systems are really, really small computers, right? Right now, I think most of you are on your phone or on your laptop. These are, I would consider big computers and powerful computers, right? Which cost thousands, hundreds of dollars. But embedded systems can cost as low as $10 or $20, and it can already make a robot around that embedded system. All right, it's a specialized hardware, and you can learn a little bit of programming to make something simple like make an LED blink or make a sensor. For example, if there's someone coming into your room, and then you put a sensor there, you can detect that someone has entered, and then it will probably make an alarm or something like that. So this is the knowledge of programming and integrating specialized hardware. It's called embedded systems. So one of the first few languages that I learned myself was C, and it's pretty hard. It's pretty hard to start learning from C. So right now, currently, Python is the easier route in to start learning. Right? There's many different kinds of syntaxes, many different kinds of basically how the language was structured. So Python is one of the more famous languages right now, and it's equally powerful as it is easy to pick up. All right. So after learning the key concepts, maybe you can go on to learn about C or C++. But if you are a hobbyist, you want to create something off the shelf, you want to create, let's say, a robot right now, Arduino is a great way to start. Right? Arduino uses a version of C programming language, right? But the key thing about Arduino is that there's so many resources online. There's so many tutorial videos for you to learn from. And once you made that thing move, you get the satisfaction, and then like, hey, let's try another project. So that's one of the fun parts about robotics. It's a very steep learning curve, but once you reach there, the steep just gets lower and lower and lower. Right. So that is from Arduino. But um, if we move forward, what we can do is level up to the Raspberry Pi. Raspberry Pi is a single board computer that can help you do more complex calculations, etc. I'm nerding out right now, but Raspberry Pi, as funny as it sounds, is actually a very powerful computer that can actually do autonomous navigation. In a project I did 3 years ago, I made a drone using a Raspberry Pi, and then it flies around, and it came back to me. I can do all sorts of fun things, and there's a lot of resources. That's the key thing about the Raspberry Pi. Okay, maybe we can move to the next slide. All right. So the key skills that I've basically have a blanket statement over. Firstly, your CAD, your computer aided design, your mechanical. If some of you are from mechanical engineering, that is one route for you to begin in the robotics industry. And some of you maybe in engineering doing electrical or electronics. This is also an essential skill. And then chances are, if you are doing that, you might also bump into embedded. All right. And then right now, I'm moving into another field, which is a little bit about software engineering. And this is where the AI part comes in, right? So the software. So some of the other skills I put there, image processing. It's one of the easier examples to share. All right. So I'll share a bit about image processing. So image processing is often used in automation to inspect products, like what you see in the video earlier on, right? So when you inspect products, it captures the image using cameras, and then it will process and say, hey, is this product, is there a defect or not? If there's a defect, okay, I throw it out, right? We using our human eyes, we are quick to detect, but sometimes we get sleepy, right? but having a camera there with some image processing involved, it will detect and then it will, like I said before, it will carry on 24/7. As long as there's power, I will still continue inspecting. Right. So the key part about image processing is that you can use it in many different types of application. So one of the applications that I verbally shared with is quality control, right? So another way, as you can see in the photo on the left side, is quite familiar when you enter some shopping malls, etc. Is going into the shopping mall. There's a camera pointing at you after you scan your SingPass. That is another type of image processing that detects whether your temperature is high or temperature is low. Some use thermal vision, but there's also a way for you to use image processing to determine, okay, if the color is extra red or extra bright, this guy must be having high fever, etc. Right. And that is another example. One of the more common one, maybe if some of you have iPhones or the newer phones, they have facial recognition. They can unlock your phone. So that is actually image processing. That itself is related to artificial intelligence. So it sounds very cheap. It sounds very hard, but is it really hard? Right? There are many image processing algorithms that can be used to identify faults, and understanding them may require high technical knowledge. But if you are just applying them into your project or into your application, you don't need to require high technical knowledge. You just need to know how to use it, right? How to use the different building blocks. Right. The robotics industry worldwide is pretty much what we call open source, right? In fact, one of the key drivers for robotics. So what we're using is ROS, Robotics Operating System, right? In the industry. So the guys that actually created that platform is called Open Robotics, and they call it open because they wanted to have open source. And what does open source mean? Open source means that I did something, a fun project. I share with you what I did. I share with you my code. I share with you exactly how I did it. So there's no like, you're not keeping some knowledge to yourself. You're actually sharing everything up with the world. So from there, people pick up. People study what you did, and when there's so many people, in the open source community, everyone upskills faster. Everyone is learning a lot faster, right? Rather than just keeping some of the knowledge to yourself. So there's something quite inspiring or quite motivating in the robotics industry. Is the open source movement. So all these image processing algorithms, chances are you Google them right now, you can find them. So that is some of the skills. So another skill also is learning how to Google the specific thing that you want. Right? Uh, and probably I'd like to add one more part about one of the skills that are being used in robotics is being able to integrate the different parts. That is the mechanical design part, being the electrical part, and then there's the software part, and then there's the image or like the algorithms part when AI comes in. Being able to integrate them and knowing where they all come in, that itself is a core skill. So these skills are not set in stone. This is what is happening right now in the industry. Chances are, 20 years in the future, new skills, new technologies come out which require new skills. But at least we know what is happening right now in the industry. And I hope that this knowledge of these skills can help some of you in enter the robotics industry. Okay, next slide, please. Okay, so uh, right, the different depth of learning. So I was just sharing with you, some buzzwords going on about algorithms, about artificial intelligence, right? But you don't really need to go super deep to be able to apply and understand it, right? If you can see what I've done here, right? Different depths of learning. You don't truly have to be have depth to in understanding to be effective, right? But depth in understanding will help you troubleshoot problems and find best approaches. But having the ability to just apply it, right? You don't need to learn how to, create a car, right? Or design a car, but you only need to know how to drive it. You can be effective enough. So likewise, the same analogy goes into robotics, right? You don't need to learn how to grow some of the ingredients, but you can learn how to cook, right? So the one of the first few levels of software or development or some AI or machine learning practices, right, is having a drag and drop software. And that is what we call very high level function. And very high level doesn't mean it's harder. High level in the software world actually means it can be easier. It means you're looking at things in a bird's eye perspective, from the top view. So you can learn to code in a drag and drop manner, right? A lot of kids right now, from what I learned from my peers who are working in the early childhood industry. Some of the parents want to upskill the kids at a very young age, get them exposed to programming. They learn not by coding, they learn by drag and drop, right? So it becomes more process oriented. So what comes after this, right? And what comes after the next? And I've seen a lot of marvelous things created by kids that use this drag and drop software. And if you're interested to know more about this, I'm not an expert in the early or the primary school level robotics, but I know they use this thing called Scratch. And Scratch is online, it's free, you can try it out. And I've seen people create games out of that. Kids 9, 10, 11 years old create very, very fun games just by drag and drop function. All right, so and next up we're going into another degree of difficulty and depth of understanding. Going down is the ability to use different image processing libraries, right? For example, if we want to, sorry, not yet. Go back, please. Right. So if we learn the libraries, what we call libraries are data sets, right? So for example, in image processing, if we want to learn how to scan, let's use quality control as an example. And if you want to scan, your product, right? You would take different angles. You would take photos of different angles of your product. So that itself can become a library. So the algorithm will learn more about how the product actually looks like. So when the camera takes a photo of it in any kind of angle, yeah, it would be able to detect it. So there's many different kinds of libraries for many different kinds of products, and being able to learn how to use them comes down to another level of understanding. And then you start to learn the concepts. And then the last level, not the last, but a more advanced level is to understand the mathematics behind this. Right? There's a lot of algorithms that go beyond this. And one of the key things I just want to share is that Pythagoras theorem. Right? A lot of us, we learn it in secondary school. And then Tuakaso, it's quite a dreaded formula once in my life, but it becomes a key part in our lives right now. The very fact that we use Google Maps or Waze to get our way around, it uses the basic concept of Pythagoras theorem, right? It triangulates your position here on Earth and where you're going to next by triangulating the satellites. So even simple concepts like the Pythagoras theorem that we learn in secondary school are actually being used, in front of you right now on your phones when you're going out. So, we use different kinds of other algorithms for different settings, and that's where the depth of understanding can come about. To be more, to have a deeper understanding uh, in robotics and in AI. Next slide, please. So it sounds very chim. It sounds very complicated to go about it, but maybe this is one of the approach that I'm aware of. Especially maybe some of you are just graduating out from diploma. Some of you are learning from WSQ courses, but there's many different ways for you to go about acquiring this knowledge in robotics and upskilling yourself to be a robotics engineer, etc. Right, one of the ways that I know of right now is that you go through WSQ courses or skills futures short courses, right? I think most of us Singaporeans are given $1,000 credit in skills future credit to be able to use them in a host of in a variety of different programs that we can join, right? And make full use of these credits, because these credits are gifted by the government, and we can make full use of these credits by picking up something that we really want, right? And who knows, right? The short WSQ course might be the spark that make you want to learn more. All right, and then of course we cannot take away your diploma certification. You've gone through a whole three years learning the fundamentals, and learning as close as possible to what's happening in the industry. So, but if you want to have a more compact more compact learning pathway, is you can join some skills boot camps, right? I'm not an ambassador for any kind of company, but I've heard different things like different boot camps. Some of the more known ones are General Assembly, where they put you through 3 months or 6 months or something like that, and then they cram you with all these skills, and then you go on to apply them, and some of the graduates actually go on to learn more and pick up more. And then it comes to something that I myself is running, which is the SG United programs. Right now, some of the workforce are being displaced due to the pandemic, right? So what the government has done is the government initiated the SG United program, and these programs, what they do is that they put some of the current workforce into 6 to 9 months long programs for them to learn more about the industry, and pick something up, and eventually be skilled enough to join or enter the specific industry that they're in. So this is an initiative by the government. They pump a lot of money in it, and then they are hopeful for the current workforce to pick up skills through this. And then another way for you to increase your level of understanding is definitely through work experience. So this will be a long route, but of course with experience you will garner your different depths of understanding. And I put there the last one, university education, doing research. Of course, that is doing a 2 year, 3 years thesis on a particular topic that will give you your depth of understanding. But some of the pathways, right, to get you started is WSQ courses. You can go through your diploma courses. There's no one right way, so explore your different options, and explore how you want to get about to pick up your skills in robotics. All right, next slide, please. Okay, so this is the last part of my talk. If I have if there's any questions before I carry on to the last part, maybe I can answer them now in case some of you have some burning questions to ask.
Yes, I mean, I think
Okay.
there's one on the chat. It's from Zailani Astral. So he asked, for hobbyist or beginner to robotics with no mechanical or electronics background, what software or platforms do you recommend? For the CAD software, is using SketchUp sufficient?
Okay. Zailani Ashral. Thank you for your question, Zailani. And I think SketchUp is a great way to start. SketchUp is also one of the more famous hobby level kind of software. The key thing is to have is the software is accessible for you, and another key thing is that the resources for you to learn is accessible for you. If you can YouTube, chances are there's someone there that is doing tutorials for you to learn, right? And SketchUp is one good way. Personally, I would recommend Tinkercad, and it's one of the easier ways. It helps you build your CAD software. It helps you build your computer aided design using blocks, and then you cut them off. In fact, I taught my dad. He's 70 this year. I taught my dad how to use Tinkercad for his computer aided design. And the first thing he designed was a chapal. So he's 70 years old. He's not the IT savvy, but he's able to pick it up. So that is for computer aided design. And for electronics or software or platform, I would recommend Arduino. It's a great way for you to start. Again, I think if you go find an Arduino board, I think you can find it sub $30. You can start creating your new hobby, and this hobby is it can go way beyond just hobby. I've seen these Arduino boards in $50,000 machines that go on 24/7 for the past 6 years. So it can be from a hobby level. It can also become part of an industrial machine that goes on and on. So I hope that answers your question. You can definitely use SketchUp. I also recommend you to look at Tinkercad, and you can also look at Arduinos for you to start for your hobby. So thank you, um, Zalani. Okay.
Thank you, Amir. I think there's another question, but maybe we take this after your portion here. Yeah, I think it'll be more applicable.
Okay.
Yeah.
Cool.
Wait, there's
Thank
another
you.
one. From Nivea. So I'm a development engineer at Sesto Robotics. What are the career growth for deployment sector in Singapore? Already have a bachelor degree. Do you suggest it for a master or grad diploma degree for me to specialize in a particular department?
Okay. Sure. I can answer that. Okay. So Nivea, deployment engineer at Sesto. I've known some of the guys at Sesto as well. Um, but what are the career goals for deployment sector in Singapore? I think when you're mentioning deployment, I think when you deploy some of the robots on the ground, uh, another word for it is also like field engineers, etc. So I think what you can do with your bachelor's degree is one of the ways you want to level up is master's or diploma degree. I would think there's two ways to go about this, but right now these two ways are not the finalized option, right? So having a master's will definitely gain you some more insights into that particular sector, and bring you another level of understanding, right? But having a grad diploma degree, usually you want to go more on almost touching base on it. So I would suggest this way. Maybe you can use a skills map, right? So the Ministry of Manpower, yes, the Ministry of Manpower, the Ministry of Trade and Industries and MOM has conducted this study where they have mapped out the different skill sets that are useful in different industries, right? And there's a skills map for retail, there's a skills map for finance, there's a skills map for engineering as well. So I would suggest maybe you can take a look at the skills map for robotics. Um, so robotics right now is a pretty new sector. There's no skills map for that, but you can look under precision engineering. You can look under infocom technology, right? So like I mentioned before, robotics is pretty widespread, right? And it covers multi-disciplines, and it just just you maybe you want to try to see which discipline you want to go into, whether you want to go into software or whether you want to go into uh, safety. That's even part of robotics, or you can go into mechanical design, etc. Right. So hopefully, Nivea, you'll find what you want to specialize in, and find a way using the skills map. And you can Google that, the skills map. You can Google that in either in precision engineering, or you can Google that in infocom technology industry. Right. So maybe I can take the rest of the questions at the end of this segment.
Yeah, sure, Amir. Thank you.
Juliana. Okay, good to know that we have some, some people on the field right now. Some people from Sesto. Good to know that they are also, practitioners. They are also online as well. All right. So maybe this is something to share with the masses, right? Or someone who is afraid to enter the field of automation or robotics. All right. So there's in the as technology advances, there's a fear in automation and technology that will cause widespread unemployment. Is it true, and can we do something about it? Right. So there's also other fears but what we will address is whether it will cause widespread unemployment. So I have four mindsets that I want to part my talk with, and I'll share them with you one by one. And the first one is, next slide. The first slide is the inevitability of automation, right? One way or another, something will be automated, right? The first way is to cope with, automation is to understand what it is, and then market forces will cause adoption, and factory automation methods will increase its product quality while reducing labor, right? So they want to increase its productivity. It wants to increase its speed. It wants to increase, everyone wants to like something to be faster, better, stronger, and it wants to be better, right? So inevitably those things will be automated. For example, right now I'm aware that maybe I can share something simple like keeping records. In the past, maybe it was written down in books and then it was stored in files, etc. So what we have right now is, we have Microsoft Word, we have Microsoft Excel. Everything is digitalized now, and a lot of these records are being kept in these softwares, right? So it's being automated in a way. And then I'm aware of this technology called RPA, which is robotic process automation. So right now, what we're doing is we're keying in data into these cells, we're keying data into these forms. With RPA, is actually automating this for you. Let's say you have a form, and then you have you wanted to transfer it to another, you want to transfer it to another form so that it is in your system. So RPA can scan using object character recognition, sorry, optical character recognition. It scans and then it sees the different words that are there, and then it auto fills up these forms for you. So even even these administrative duties can be automated. So yeah. And then I can also give examples in the manufacturing line. Sometimes you have human labor there, right? So robots can also take over that. But there's a ultimately robots can work 24/7. Robots they don't need rest, they don't need off days. And this is one of the things that will happen because they need higher throughput. But there are ways that we can adapt to the changes in robotics, right? And I'm going to share with you also on the next slide, the next mindset. So the first mindset is the inevitability of automation. uh, yeah, so the last point before we go to the next slide is we have to find the best strategy to get ahead of this trend. Next slide, please. Right, the next slide is to complement your current skill, right? So some of you may be already skilled in a certain industry. You may be skilled in maybe mechanical engineering, for example. But you can also get ahead of the trend by learning new skills that can complement your current skill. So let's say you're a mechanical engineer, and you can learn mechanical engineering skills and automation. And if you're an admin clerk, you can learn programming, and you can automate business admin processes. You can automate that as well. Um, so equipping yourself with automation skills will enable you to seize opportunity and be the one implementing it, or you design the system when the upgrade happens. So ultimately, what it means when you complement your current skill is that you don't throw away your old skills, right? Your old skills are still being used. It's part of like what makes you special when you pick up your the skills that you've garnered over the years or gone through in school, in diploma, in uni. When you learn new skills, they are meant to complement what you already have, and then you become a unique breed of your own. Maybe you have a real estate agent, right, who's starting to learn programming. Maybe he can learn to start to automate his own transactions in real estate. It can work out that way. So that is one of the mindsets that you can have, is to pick up new skills that can complement your current skills, but don't throw your old skills away. All right. Next slide, please. Right. And then the third mindset that I want to share is that automation technologies they're not hard, right? There are varying degrees of competence and depth in understanding for any given automation skill, but you don't have to achieve the deepest understanding to be useful. You don't need to study all the way to PhD for you to enter the robotics industry, right? You don't have to spend years of research, right? Maybe those are for people that are really thought leaders in their specific industries. So with advancements in technology, advancements in ed tech, for example, it makes learning easier, and simple things like YouTube, right? Having someone post their tutorials online for us to learn there for free. All we need is just Wi-Fi. Right? These technologies are not hard to learn. In fact, there's a lot of I was mentioning about SolidWorks being a computer aided design. There's a lot of YouTube videos, tutorials sharing how to do best practices to design something. So automation technologies are not hard. that is the mindset that we need to have so that we can ultimately get over that barrier and pick up new skills. Next slide, please. And then the last part, which is one of the most important things, I believe, is that you should exploit increase in productivity, right? What does this mean? I'll explain in a while. Increased productivity means that a single operator is able to achieve high throughput with automation. So automation can be mechanism to alleviate mundane jobs from human workers, right? Then it will create meaningful and higher paid jobs. Therefore, it's driven an optimistic mindset is advantageous. Again, it's a mindset, lah, right? So when you increase, when you find ways to increase productivity can mean different things, right? It can mean run faster. It can mean arrive sooner. It can mean look better, right? Any sort of performance driven goal is increase in productivity. So as long as you can do the job better, that itself can be used, right? You are actually making it better. You are actually creating more value and increasing the your level of productivity. So as long as you can exploit the increase in productivity, I believe you are already in the right mindset to pick up robotics and automation, right? So with that four mindsets that I've shared, hopefully it opens up your it opens up certain eyes and certain doors to think about automation and robotics in a different way, and sometimes it makes the job better, it makes the job more meaningful, and like what Liana said earlier in the opening statement, certain jobs were not built, yeah, certain jobs were not available or were not they did not exist 10 years ago, right? Only with current technologies that these jobs exist, right? So with jobs being depleted, more new jobs will come up with the increase in technology, right? So I hope these four mindsets will help you with your way in your journey to learn more about robotics, and I hope the skills that I share will be fruitful for you in the future. Next slide, please. All right. Maybe we can share the next slide. All right, so that is the end of my slide. This is one of the robots that we manufacture in-house as well. It's a robot arm, and you can keep in touch with me. That's my email, and you can scan my QR code to my LinkedIn. Then I hope this talk has been fruitful, and maybe now I can take some Q&A to share.
Yes, thank you so much, Amir, for sharing about what are robotics, to what are pathways, and your personal opinion on the four different mindset that you want the audience today to take away with. So we have some questions on the chat here. I think we can address Said's question. Can you explain how employment increase with automation and robotics advancement in the future? So we touched a little bit on it right just now about
right.
Yeah. So Anis, do you have anything else to add?
Oh, okay. Right. So with the increase, maybe we don't need to talk about automation or robotics. Maybe we can just, in general, talk about technology. So the advancements in technology creates more jobs. For example, who would have thought 10 years ago that there will be such a thing called social media influencers? There was no social media back then, right? So these new technologies creates new jobs that we wouldn't have even have thought of. Right? And I'm pretty sure in the future that there's new jobs that come up that we or myself haven't had the foresight to see, and I've seen this in business owners moving some of their business online through the pandemic. I've seen a lot of people selling stuff online with the Facebook Live and etc. And this is made possible with the current technologies and the advancements in technology that are available there. That's how I would answer. The increase, employment will be increased in the future.
Right, and it also pushes, like, with rise of technology, it also pushes us to learn new things, and then that itself will create jobs in terms of like teaching, in terms of redefining or refining the things that we've learned. And he also asked another question, comparing us with other robotics arena to a bigger technology country like China and India, what are the challenges to make us stay competitive? What are your thoughts on it, Ami?
Oh, great question. This is a really great question. China and India, no doubt, they are powerhouse in technology, right? A lot of the stuff really, affordable, and at the same time with high quality, with Huawei phones as one example to quote, right? Amazing technology from China. But what makes us competitive is our, I believe Singapore as a neutral party to a lot of different countries, and also as a business hub, right? Ultimately, what makes us competitive is our ability to be is have bilateral ties with a lot of these powerhouses, meaning it's able to share some resources and get some resources with powerhouses like China and India. And having and being diplomatic and being a neutral party, right? It makes us competitive in a sense that when China shares some of the technology, right? Singapore, some of the universities in Singapore are being invited over. In fact, my team, when I was 2 years back, I entered a hackathon, which eventually we won. We were invited to China in Nanjing. Yeah. So over there, that's where they shared what some of the amazing technologies, and it was one of the cities in China that completely zero carbon or carbon free. So they were either cycling or using electric bikes, and having that neutral ground with China, I think that makes it possible for businesses to happen. When businesses can be moved, that's where more things can be implemented, and when more things are implemented, that is where these products or this technology is being made available to the public, or to the masses. So I think, in my personal opinion, Singapore being, its diplomatic stance, I think that's what actually makes us competitive. We are, friends with everyone, and we get help from here and there, left, right, center.
Right, this is actually true lah. I mean, there's always something to learn, right, from other countries as well. I mean, if they come out with something new, then we've learned from them, and never know that different minds in Singapore can actually innovate something else. Maybe I can just take one last question from one question which is from the registration form. So we have a young professional who asks, I have experience in handling basic ABB robot movement and robotic programming. How do I move forward in my career deployment from here? Yes.
Interesting. First of all, congratulations in landing a job in ABB. ABB is one of the first robot manufacturers ever. So there's a big legacy there. Right. So being a deployment engineer and learning how to control robots are one part of it. But having the ability to, I'm sure when you are deployed to the ground, you're able to see the whole ecosystem. It's not just the robot arm that is there moving. There's a whole list of different peripheral technologies that are also part of that circuit, what we call. Right? There's a camera, there's a conveyor belt, there's the grippers. I think one way that you can move forward as a career advancement is learning these different systems, right? Learning about these different systems and learning how they come together, and ultimately work your way to, be a system integrator, right? System integrators are basically solution providers for companies lah, and give them ideas on how to solve it. So yeah, I wish you all the best in your career, and hopefully that can give you a more directed approach. I think being a system integrator is also a rewarding career as well.